Well, welcome back, everybody. I have labeled all the wires coming out of the capacitor, the RF capacitor, RF bypass capacitor can. They are labeled. Now what I've got to do is I've got to bend these tabs and pull it out. And then from there, we'll have to melt the tar, and then we'll have to build a board with some capacitors to go back in that can. Alright, I've got that out. This is some sort of cardboard material. There's the reference number on it. So have to bend these back, take this apart, and then heat that tar. Try to get that out. That's going to be the fun part. Let's go for it. These tabs are difficult to bend, but I got them, and I got the cover off of it, and as you can see, tar. I am going to try something different, and let me try it and see if it works, and I'll let you know what it is. Even if it don't work, I'll tell you what I tried. Well, there it is, guys. Out slicker than a whistle. I think this has been hot at one time, because I saw a little seepage coming out. And when I went to take the cardboard out, the cover, I put a screwdriver in and pried it a little bit, and I heard it go pop all the way down. And I thought, this thing may not be stuck that good. So what I did is I took a little mini torch and heated it for about 3 minutes, and grabbed the rabbit by the ears. And the can was not even hot enough to burn my hands, and I held it barehanded and pulled it right out. First try. Not a problem at all. Alright, now we got to figure out, we got to get a board and start building our capacitors. And let's see, here is the schematic for for all the capacitors. So we'll start working on that, and I'll show you what I've got as I get along. But take a look at that. Look at those capacitors. Got a good look at them here. And these are like 0.5s, and maybe there's a 1 in there somewhere. But they just, in 1931, they just didn't have the technology we've got today. I'm glad it wasn't a bigger mess than that. Well, I had planned on taking and soaking this overnight in mineral spirits to get the tar out, but when I went and put the mineral spirits in it, it just started, all of it started coming out, and I rinsed it out and scrubbed it a little bit, and that's pretty much it. I may hit this with some paint later. I'm thinking that this board may be good enough. I think there's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 capacitors to go on this board, and this is the largest one to go on it, just one of them, and I think that's going to work fine. I'm going to go ahead and make, it may waste a little bit of wire. The shortest wire coming out is about 8 inches. The longest is about 10, so I'm going to make them all 10. That way I'll have plenty to work with. And so we'll go from there and see. We'll build this board. I'll line this with cardboard and make a sleeve to go in it. And we'll rebuild that. In the meantime, I'm going to rewire the heater. They are really brittle. Now, they used brown wire on all of them, so I'm going to go back with green. I mean, I don't have any brown, but I'm used to everything being green, so I'm going to go ahead and use green. So, I don't know what I'm going to do. The transformer wires are kind of brittle on, so I may end up put some heat shrink on those to protect those. But once I get some of this wiring out of my way, then I can clean the chassis. I'm going to make a cardboard liner for the capacitor can. I'll try to do it in one piece, using all those skills that we learned in kindergarten. And you remember those tests where you see how things are folded in your mind and how they look afterwards? I use my Raisin Bran box, measured it out. I'm going to try to fold it and make it in one piece. There it is. Okay. Went to build the capacitor board, and this is the schematic. It has a brown wire, a yellow wire, and a black wire. The black one is common to 4 capacitors. The yellow is only to that one capacitor. Now the red one is common to 3 capacitors, and the brown is common to 2 capacitors. So you had to keep it kind of halfway straight. I told you I didn't have any brown wire, but I used a wood finishing marker to make my white wire brown. So then I used other magic markers, the red one to make the red on the yellow wire, and I took the black one and put black stripes on the red wire. So all the color codes are as the schematic calls for. So here's what I came up with. All the capacitors. I end up wrapping it to the board itself. This is actually 2 boards, and I glued them together to make it long enough. The board could be anything from phenolic, plexiglass, a piece of plastic, whatever. It didn't have to be any type of PC board or anything. All the connections are made to the wires and the capacitors. So now I've made this, and it will go in the can like this, and I need to cut a slot in this here so that I can put the other piece of cardboard that actually came in this. Let me cut this, and I'll show you what I'm talking about. Okay, I've cut that slot. This will go in there, and I did check all these leads and the capacitance to make sure they were correct, and they are. So then we'll just fold that down like that. Now, will this fish? Can we fish this in here? Yikes. What if these wires are too big? Didn't take that into account, did I? Yes, I did. I fitted it first to make sure. Alright, we're going to check the output transformer and the interstage transformers, which is located in this back center can. I kind of alluded to maybe a possible problem, but we're going to check and verify that at this point. Now, if we look underneath, I've done disconnected most everything, so I'm going to have to trace some wires. We've already tested the field coil over here on this part of the schematic. So the output transformer is here, and the interstage transformer is here. This is where it comes from, the 27 tube, and then it takes and puts it to both the 45 push-pull output tubes. So let's check this winding here. This is the secondary of the output transformer, which will probably be low, have a low resistance. It doesn't say what it is on the schematic, so I guess it wasn't enough to include in their drawings. They included a lot of others, but not this one. But it shows it going to chassis ground. Well, the transformer, I had to look on the actual wire layout drawing that I have, and I have lifted that wire because I've removed the board and several of, and the capacitor cans. So that is no longer, it is a chassis ground, but we'll have to look. It's a black wire, and the other wire that's coming out here is the one that went up through the top and went to the speaker itself. So it'll be this wire here that I have marked, and then the other one is one coming out of the transformer can here, and it is reading, let's settle out, 0.8, 0.7 ohms, which we said it would be low. So we're saying this is good here. So let's check this winding here. It's got a center tap also. Well, these were red wires. You notice I colored it in according to it. Now, it's really hard to tell. Some of these wires are actually the colors that they say they are because of the fading and everything like that. This should be reading about 360 ohms, and it should be pretty easy. All we have to do is go to the plates of the number 45 tubes respectively and just tie across there. So, and these tubes here are the 45s. Let me find all my leads here. Okay, here's the 45s. This is pin 1, so this will be pin 2 here. So we'll clip on that. There's pin 1, that'll be pin 2 there. So we'll clip on that, and it should be somewhere around the order of 360 degrees. And the other end of my clip, look at this, guys. I removed the wrong clip. It should be on my meter. Okay. That's one of those oh no's. Anyway, should be reading 360 or so here. We're getting 376.8, and like I've said in previous videos, these are calculations. The technician in those days did not have anything that could read, to the exact digit like that. So that's good. Now the center tap is a red black wire. So this would be this one here. So if we take and alternate these, we should have approximately half of that. And so that one is reading 179, we'll call it. And then if we just go and swap, we leave that on the center tap and come back to this one, we should have approximately the other half. That's 198 versus 179. That's about 20 ohms difference. Now you'll find that in your some windings that are secondary. You know, it's got center taps to them, and the reason being is the windings, one half of the winding of the transformer is wound, and then the other one is wound on top of it. So the winding that's on top is further away from the core for the induction of the electromagnetic field. So it has to have more wire for it to be equal with the second one, though. So that's why it has more resistance to it. All right, so that checks out pretty good. So now we're going to go to the interstage transformer. So let's go ahead and do the primary side of this, which should be reading about 720 ohms. And this one goes up to the RF choke that's coming from the 27 tube coming around, and then this goes to the B+. The B+ is fed through this also. So let's find those wires. I've got them pre-marked somewhere here. So this is one of them here. Okay, and then the other one is a green, I call it a green 15, and it's hard to find them sometimes. I know I've had it. There it is. So this should be reading about 720 ohms or so, and we're reading about 698, which that's all good. That's not a problem. Now let's go to the secondary of this one, and as you can see, they go to pin 3 of the 45. So all we got to do is go to pin 3 and check that whole loop. It should read about 5,700 ohms. All right, I've already disconnected one. Here's one of the pins here, pin 3. 1, 2, 3. It's still connected to the tube socket there, and I have disconnected one, and that's it there. So let's connect it to that, and we should have about 5,700 ohms. Make sure I get a good connection. Seems to be open. Now yesterday, when I did this initially, I could wiggle that and get an erratic reading, and I think a lot of times corrosion has a lot to do with these failures of these. This one has failed. So let's go to the center tap and see. So we've got a black one coming out, which actually goes, it comes out and goes over, and it takes the bias for those tubes between the 100K resistors here and runs over to the center tap of that transformer. Okay, so it should be approximately high to one of the sides or so. So let's see if I can find it. That's on both the windings there. And just bear with me, guys. It's a black number 3, which should be somewhere in here. I believe this is it here. Yes, this is it right here. So let's go to it and see if we get any continuity at all. I have none. Now let's go back. I take that back. This is, I'm sorry, this is the center tap. Still nothing. And then we'll go back to this one. So for whatever reason, I'm getting no continuity through that, through this part of the circuit. Now it was playing. How was it playing? Probably was an intermittent problem, and through all the agitation and vibration and pulling and tugging, it finally failed. So I have ordered another transformer to replace this. I have not. This one is still good. Now, in afterthought, I'm thinking maybe I should have ordered this one also, because I'm going to have to take that can apart and it's full of tar. So I'm going to have to take these two transformers out of that tar, hoping I don't destroy this one in the process to replace this one. So this one will take a universal output transformer. I'm thinking about going ahead and ordering one to have it on hand. It's something that's generic. I can use in other sets, so that's not a problem ordering and having it. And I'd rather have it not need it than need it not have it. But I guess I'll go ahead and order that today. But you know what that means, guys? That means we're going to have to bend these tabs and pull the rabbit out of the hat here, and then take that apart. So here we go. And then this will be even more a strip chassis. I think I said in an earlier video that I was going to just replace these heater wires with green wire. I've changed my mind on that. I went ahead and when I ordered that transformer, I went ahead and ordered brown wire to replace the heater wires with the original colors. So that'll be coming the same time, so that's where we're going to be at. So let's tear this thing apart even further. Alright, what I had to do to get those lugs started is I took a little bitty screwdriver that had a real sharp edge on it, and get right up under the edge, and then I used a real heavy duty screwdriver once I got that under there. And then once I did, these flat slots right here, was able to just straighten it right out. Now I don't know if you can see, and I don't know if we're going to be able to get anything out here, but as you can see, tar. I can see one transformer right there, and if I'm lucky, it might come out easy. I don't know. We'll take this outside because this has a little bit more tar in it than the other one, and it's chipping away. So I may end up just trying to chip it out for a little bit and see where we go. I got the first transformer out. As you can see, and this I didn't do this damage to it. The laminations were already coming out of it. I mean, look at it. They're every one of them is wiggling, is loose. So that's the way it was. I didn't do any damage to it at all. What I end up doing is using a screwdriver and chip the top tar off, and then it dislodged. And this is the one that was open. So it's possible we could go in here and maybe find it, but with that core like that, that's I'd say it's almost it's not going to be usable. Probably take it all apart, clean it all up, rewind the coils, and put it all back together, and it'd probably be fine. But that'll be for another day. Now the other one is still embedded in the tar, and I don't think I'm gonna be so lucky to get it out. But I used a little bit of torch, not a whole lot. But I don't know if you can see down in there or not. But there's cardboard on either side, so I'm thinking that if I chip some of that tar out, that this one will also. Now the reason I want this out too, I want to clean the can up for one thing, And I don't know exactly the physical size of the next one, so I'm going to have to rearrange them. May have to rearrange them to make sure they fit in the can properly. So I definitely want to get this out and without damaging it, if I can. And so let me do a little bit of chipping. Okay, I got it out. Now the cardboard was in there for a reason. That cardboard was sitting in the can that way, cradling the transformer, and it actually kept the tar from sticking all the way around. So once I broke away a few pieces here and there, I was able to lift it out. So that was a good thing. You can see there's still a little cardboard in there, but all in all, the can is relatively clean. Clean that up with a little mineral spirits and I'll be good to go. Now this is the output transformer, and look at the laminations. Same situation. So I don't even know if I'm going to even try to clean this up and use it, because this is not damage that I done. This is just, if you can see it wiggling there. So I think what I'm going to do is go ahead and order that output transformer and just replace both of them while I'm in here now. I may, like I say, go back on another day and fix and rewind these and have them for either spares or for maybe another radio that may get down the road. Okay, I think we're going to wrap up the video, this part of it. All I'm going to do is clean this can up and wait on some parts, and then we'll pick up where we left off here. But I picked up a few more subscribers this week. I appreciate that, and I appreciate all the comments, and give me some feedback on the audio and the video. I've changed cameras and mics, and I want to see if it's an improvement on your end, because I'm making these so you'll be comfortable with them, not necessarily me. So let me know, give me feedback. I appreciate the comments. So, from Larry, from the hills of Tennessee, thanks for watching.